Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss about 23 ITT 301 Microcontroller and Embedded System subject under the topic Microcontroller Peripherals. So if you watch my previous YouTube video, you have a knowledge about how a microcontroller is working and the various pins inside the microcontrollers are discussed. Now I am going to discuss about microcontroller peripherals. Remember that a microcontroller is more than just a microprocessor. Subsystems within the microcontroller that are dedicated to a specific functionality are referred to as a peripheral. For example, an microcontroller unit communicates with the digital accelerometer through a I2C protocol. It will need an I2C peripheral. And microcontroller unit reads an analog temperature sensor. The analog sensor needs to be converted to digital, so it will need an ADC peripheral. And microcontroller units needs to keep track of time, count how many seconds have passed between events. It will need a timer peripheral. So there can be multiples of same peripherals on one microcontroller unit. Some common types of peripherals found in microcontrollers are general purpose input output pins, timers and counters, pulse width modulation controllers, analog to digital converters, digital to analog converters. Let me see individually. GPIO pins, that is general purpose input output pins. These provide a fundamental way for the microcontroller to interact with the outside world by reading or sending digital signals. Timers or counters. It is used for measuring time intervals or count events, enabling tasks like generating timing signals or implementing timing outs. Pulse width modulation controllers. Special timers that control the average voltage output of a pin by rapidly switching it on and off, useful for controlling brightness or motor speed. ADC, that is analog to digital converters. It converts analog signals from sensors into digital data through the CPU can process. DACs, that is digital to analog converters. It converts digital data from the microcontroller into an analog voltage used for generating audio or control signals. Serial communication controllers, something models are UART, that is universal synchronous asynchronous transmitter, SPI serial port interface, I2C, USB. These handle communication with other devices by sending data one bit at a time. Examples include UART for simple communication, SPI for faster data transfer, I2C for communicating with multiple devices on a bus, and others like USB, CAN and Ethernet for various applications. Memory. Microcontrollers typically include both non-volatile flash memory for program storage and volatile RAM for temporary data. Interrupt controllers. These alert the CPU to events from other peripherals, allowing it to respond quickly. Direct memory access controllers. It enables data transfer between peripherals and memory without involving the CPU, improving the entire efficiency. Watchdog timers. It resets the microcontroller if the system encounters an issue, aiding its recovery. So here is a list of some common peripherals found on many modern microcontrollers. GPIO, general purpose input output controller, to user to basic input output interface. UART, universal asynchronous receiver transmitter, used for serial communication protocol. SSI, synchronous serial interface, used for serial communication protocol. GTAG, joint test action group, it is used for programming and debugging interface. USB, universal serial bus, it is used for high speed serial communication. ADC, analog to digital conversion, it is used to convert analog signal to digital values. I2C, integrated communication, it is mainly used for serial communication protocol. So CAN is called the controlled area network. It is used for vehicle communication standards. Timers, it is used to count the clock signals, that is it will keep track of time within the microcontroller. Ethernet, it is a local network communication interface, local area network communication protocol. Analog comparators, it is the device that compares two voltages or current and outputs a digital signal PWM, that is the pulse width modulated signal, a pulsed digital output used for communication and control of analog devices. So these are some examples of the peripherals. Why peripherals are more important? It increases the functionality, that is peripherals enable microcontrollers to perform a wide range of tasks from controlling motors to communicating within the internet. Improved efficiency, by offloading tasks to peripherals, the CPU can operate more efficiently and at a lower power consumption. Flexibility, peripherals allow microcontrollers to be used in a variety of applications from embedded systems to industrial automation. So thank you for watching my video. In this YouTube video, I discussed the various important peripherals used in microcontroller. Next video, I will bring some new topics. Thank you for watching my video.